Hi, I'm Minjun Choi, and this is my final project for the CS 6460 Educational Technology course on the development track. My project is an LM-assisted rubric-aligned writing feedback tool for short answer and explanatory responses. In this presentation, I'll briefly introduce the problem I'm targeting, show the tool I built, talk about how it aligns with assessment principles, and share some key results and lessons shared. In many writing-intensive courses, feedback on short answer work is delayed, inconsistent, and often not very actionable. Instructors are under time pressure, so comments may be very generic, like good work, or overly focused on surface level issues that don't really help students revise. As more of this assessment moves into digital tools, those weaknesses directly affect validity, reliability, fairness, and accessibility. We need to know that feedback actually reflects the construct we care about, that different raters are responsibly consistent, that the experience is accessible, and that instructors can understand and trust what the system is doing. Practical concerns also matter. If the tool adds too much workload or creates security or governance problems, it won't get used. So in this project, I explicitly treated assessment principles, validity, reliability, fairness, and accessibility, transparency, and practicality and security as design constraints for both the tool and the evaluation. The main audience for the tool is instructors who grade short answer or explanatory responses with a rubric. The core flow looks like this. First, the instructor imports a rubric and loads a batch of responses. Second, the system generates draft, criterion level feedback for each response. Third, the instructor goes through a human-in-the-loop review flow to approve, edit, or reject each feedback item. Fourth, finally, they export approved feedback in a format that can be shared with students or brought into another system. There are two main views. One is a student-facing feedback card view, where each card is tied to a rubric criterion, a rational, and an exemplar. The other is an instructor collaboration and metric views, where instructors can see agreement statistics between raters and focus on disagreement cases. In all cases, feedback is only sent to students after instructor view. The tool never bypasses the human in the loop. Under the hood, the tool uses a structured rubric model in JSON or CSV with criteria, performance levels, and exemplar text. The baseline feedback generator is template-based, not LLM-based. For each target criterion, it produces feedback that is always tied to a specific criterion. It includes a rationale explaining why the feedback is being given and includes an exemplar reference when it's appropriate. Those fields are required before export, which supports explainability. There is also an optional LM path behind a feature flag. If enabled, the model can propose short suggestions, but these still have to be approved or edited by an instructor before they are exported. The system is fully usable and fully evaluable with the template-based baseline alone. To support governance and practicality, the system keeps an audit log of rubric imports, review actions, exports, and when LMs are used, which models and prompts versions were involved. That helps with the transparency, reproducibility, and security. I structured the work across two milestones and a small micropilot. For milestone one, I built an alpha end-to-end workflow, rubric import, template-based feedback, human review, and export. I generated a sample export and drafted an expert content validity form, a usability script, and a WCAG or UDL accessibility checklist, and assistive tech test. This phase was about seeding the evaluation scaffold. For milestone two, I focused on metrics. I implemented scripts to compute Cohen's kappa on a 30 response data set for a clarity of explanation criterion and to compute explainability coverage on the export feedback. This is where the calibration and metrics view design came from. Finally, I ran a small micropilot using the live tool and calibration view. I captured approximate time on task and collected rater expressions about usability, efficiency, fairness, and accessibility. Because the pilot is small n, I treated these data as qualitative indicator rather than full-blown statistic. To look at reliability, I compared an expert and an instructor on 30 short answer responses for the clarity of explanation criteria. Each response was labeled as either needs work or proficient. Before calibration, observed agreement was about 0.93, expected agreement by chance was about 0.52, and coins kappa was 0.8618, which is typically interpreted as strong agreement beyond chance. There were only two disagreement cases. After using the calibration view to walk through those borderline items, observed agreement increased up to about 0.97, and kappa increased to about 0.93, which is strong agreement. Only one disagreement remained. The key point is that the calibration and metric view surface of disagreements and links back to the underlying responses and rubric cards, which helps Raider focus their discussion and align their threshold without re-rating everything. For transparency, I defined an explainability coverage metric, the percentage of feedback items that include all three of these fields. First, a linked criterion, second, a rationale, and third, an example reference with when that makes sense. In the milestone one export, there were three feedback items, and all three met this standard. So coverage was 100%. That's a tiny sample, but it confirms that the templates and validation logic can enforce this structure. As the tool is used on larger set, the goal is to keep explainability coverage at or above around 80% and to use the breakdown or missing field to adjust templates or UI when something is consistently left out. So transparency here is not just a metric, it's also a guardrail on what can be exported. On practicality, raters were able to complete the 30 response calibration session in a single sitting. They reported that for small calibration tasks, the workflow felt at least as efficient as their usual ad hoc process, especially because the interface grouped criterion cards and provided predictable approve, edit, reject controls. On accessibility, I implemented semantic landmarks and headings, ensured that all main tasks can be done via keyboard navigation with visible focus outlines, and tested some basic assistive tech tasks. Issues were captured in accident log for follow. On fairness, evidence at this stage is qualitative. Within the limited sample, raters felt that the tone of the feedback was fair and respectful, and there were no obvious issues. But I haven't yet done symmetric subgroup analysis or large-scale equity checks. That remains important future work. A few things worked particularly well. The template-based baseline with explicit explainability constraints ensured that feedback was structured, rubric aligned, and auditable without relying on LLMs. The calibration and metric view made kappa a disagreement visible and actionable, and starting accessibility work early rather than as a late add-on helped build WCAG and UDL considerations into the main flow. At the same time, there are clear limitations. The dataset is small. Only two radar roles were involved, and I focus on a single rubric criterion. I haven't yet run a full version of outcome study to measure student learning gains. Accessibility and fairness check were mostly qualitative and perception based, so the results are promising, but they should be interpreted as early evidence rather than the definitive conclusions. Before I wrap up, I'll quickly show the tool and metric scripts running so you can see what this looks like in practice. To wrap up, this project delivered a rubric-aligned writing feedback tool that keeps instructors in the loop and is explicitly shaped by assessment principles. The initial evaluation shows strong inter-rater agreement between expert and instructor, complete explainability coverage on the small export sample, and meaningful progress on accessibility, all within a practical audit log workflow. Looking ahead, the next step would be larger pilots across courses and criteria, more semantic fairness and accessibility analysis, and careful comparison between the template baseline and the optional LLM mode under strict governance. Thank you for watching, and I would welcome any feedback or questions.